Yo, what's going on, guys? Now we're gonna switch it up a little bit and talk about anticoagulants. And so, just to get things moving, so let's just define anticoagulants, antiplatelet, fibrinolytic. Okay, anticoagulant is exactly what it means. Inhibits synthesis function of clotting factors. No clotting factors, no coagulation. Antiplatelet, reduce synthesis activation of platelets. Easy enough. Fibrinolytic, plasminogen activator, which dissolves fibrin. There we go. Now, when do you want to use what and when? Okay, for PE-DVT, venous thrombosis, we're going to use warfarin. It's an anticoagulant. For prophylaxis of an arterial thrombosis, we're going to use aspirin. Aspirin is an antiplatelet. For aspirin alternative and post-myocardial infarction, unstable angina, clopidogrel, ticagrelor. And for coronary thrombosis, ischemic stroke, we're pulling out the big boys. It's going to be fibrinolytics, alteplase, tenecteplase, urokinase, things like that. So to understand anticoagulants, we got to draw out the coagulation cascade. Easiest way that I've remember how to do this, shout out Pathoma. Okay, you start out with X, you got 12, 11, skip 10, right? 9, 8. Then on the other side, you got 7, 5, 2, 1. Okay, for heparin, we got to monitor the PTT. Okay, and then for the PT, we got to use something called the INR. INR basically is patient's prothrombin time compared with a standard. Okay, and that's called INR. And that's how we monitor warfarin. And that should be around 2 to 3. Okay, no problem, easy. Okay, heparin, how does it work? It binds to antithrombin 3 and activates clotting factors 10 and thrombin. Now, what if you give too much heparin and you want to reduce it? You know, the antidote to heparin is something called protamine sulfate. So, protamine sulfate. For as far as side adverse effects, we're not really going to hit that too much on this video, but obviously heparin-induced thrombocytopenia is something that we should be thinking about when we're thinking about heparin. For warfarin, we're going to block vitamin K epoxide reductase. And that's basically just what we want to be thinking about when it comes to that. Now, what factors does warfarin inhibit directly? Easy. Well, if you know 2, then you know 7. And if you know 10, then you know 9. Plus protein C and S. Easy. If you know 2, then you know 7. If you know 10, you know 9. Okay, what about aspirin? Now, don't forget, when platelets bind to each other, they bind to each other with something called fibrin. And so this is our platelet here, and this is another platelet here, and in the middle right here we got fibrin. Okay, but the way the messages that platelets send, or the way that they congregate together, is through something called thromboxane A2. And so thromboxane A2 is a product of cyclooxygenase. And so that's something that like non-steroidal anti-inflammatory drugs hit. But so in the context of aspirin, they inhibit cyclooxygenase 1, which inhibits the synthesis of thromboxane A2. That's how it has its anti-platelet aggregation effect. And then when we're talking about our alteplase, tenecteplase, urokinase, our direct thrombin inhibitors, our fibrinolytics, basically what we're doing here is that we're activating plasminogen to plasmin, and then plasmin dissolves this fibrin right here. And that's it. If you like this video, thanks.